We are now looking at a teaching video on polynomials. The specific area we are looking at is factor and remainder theorem. Now we would have gone through what a factor theorem is and what a remainder theorem also is. Now we are talking about the combination of the two. So a typical question would be, you can see words like factor, remainder would appear in the question. So you can see this type of question would be the combination of the two types. Now when we look at this question, we first of all let fx be 2x cubed plus ax squared plus bx plus 2 or plus 6. And we have a factor that is x plus 2. And when fx is divided by this factor x minus 2, we get a remainder of negative 12. This is just my little summary. And you realize that at the end of the question there, we are asked to find the value of a and b. So suggesting that we would have two simultaneous equations with two unknowns, the a and the b, so that we can solve for the value of these two unknowns. So just a recap of what we had there. Let fx be the cubic expression. Now without doing that assignment statement, we have no right to go into the factor and remainder theorem. First equation to be formed, if I look at the factor theorem, so I'll be looking also at what's stated as a factor. And you can see here the factor is x plus 2. And the value of x that I would take would be a negative 2. That is when I equate this factor to a 0, and I can work out the x value to be negative 2. So going back there, the first equation would be, if I put a negative 2 in, I will have 2 times negative 2 to the power of 3 plus a times negative 2 squared plus b times negative 2 plus 6. Now, to simplify that, that would be negative 16 plus 6, and that will make negative 10. And here I have 4a minus 2b. Since x plus 2 is a factor of f of x, then the remainder is 0. So here I will equate the expression to a 0. And therefore, the simplified equation would be, if I just equate that to a 0, I have 2a I'll make b the subject. So I'll divide throughout by 2. So I have b equals to 2a minus 5. That's equation 1. Next, using the remainder theorem, I have to bear in mind the divisor is x minus 2. So if I equate that to a 0, I get x equals to 2. So that's what I will put into the fx. So here, f bracket 2, I have 2 times 2 to the power of 3 plus a times 2 to the power of 2 plus b times 2 plus 6. That will be 16 plus 6, 22. Then plus 4a plus 2b. And the remainder that I get is a negative 12. So I'll equate negative 12 to it. This is the remainder. Previously, we equated the expression to a 0 because the remainder is 0, or there is no remainder. Equating this together, I would have 2b plus 4a equals to, now if I transpose this to the side of negative 12, I would have negative 34. Simplifying that, I have b plus 2a equals to negative 17. That's equation 2. Now, you can see by just taking these two equations, I can solve for the values of a and b using the substitution method. Of course, if I did not rearrange it, then the other options I can have to solve for a and b would be by using the elimination method. Now I would like to look at some key phrases that we would encounter with questions like that. The first one, f of x is exactly divisible by x minus 1. So the word is divisible. So it means that there will not be any remainder. So if I equate this factor x minus 1 to a 0, I'll get x equals to 1. So if I put into f of x 1, then the outcome would be a 0 remainder. Another common phrase to look out for is f of x is divided exactly by x. Now, if I equate x to a 0, then I get x equals to 0, and that is what I'll put into the f of x. That will also be a 0 outcome, or it is thought of as 0 remainder. The other common key phrase would be x equals to 1 is a solution of f of x equals to 0. What it means is that if I put in x equals to 1 into the f of x, indeed I'll get a 0. Next, we say x minus 1 is a factor of f of x. So the factor, when equated to a 0, will give me x equals to 1. So if I put x equals to 1 into the f of x, I will have a 0 outcome. The last one there, f of x divided by x plus 2 leaves a as a remainder. Now, the divisor here, when I equate to a 0, x is equals to negative 2. So f bracket negative 2 should give me a remainder a. Now you see, there are many variety of expression, and there could be some that I have not covered here. But essentially, these are the symbolic form that we should get, and we work from the symbolic form. So we have come to an end of this particular video segment.